In this video, we continue exploring just the basics of exponential functions. And you might remember that in the last video, we made a few summary statements about the basic exponential function a to the x, like 2 to the x or 3 to the x. In this video, we look at what happens if we take some exponential functions and transform them, so basic transformations. So I've started us off with something that we did in the last video. So I graphed f of x equals 2 to the x here, and I reminded us of the domain, the range, and the asymptote. In the list here, I wanted to do 4 examples with you of transformed exponential functions. So for the first one, we have g of x is equal to 2 to the power negative x. You'll notice that for these examples, we're going to list the transformations, find the domain, the range, and the asymptote, and then we'll also sketch the graph. So in purple, what transformations do we see? Well, x has been replaced with negative x. So what would be really great is if you said it with me. What transformation do we have here? This is a reflection in the y-axis. Okay, so as many of you said in your summary of the videos we had from the transformations unit, the reflection in the y-axis does not affect the y-coordinate. So if you start with a point on the graph of f, so let's call such a point xy, the x-coordinate gets reversed. It becomes negative x. The y-coordinate stays the same, okay? So 0, 1 stays put, right? Since the x-coordinate is 0, the opposite of 0 is 0. 2, 1, 2 becomes negative 1, 2. 2, 4 becomes negative 2, 4. 3, 8 becomes negative 3, 8. Negative 1, 1/2 becomes positive 1, 1/2. Negative 2, 1/4 becomes positive 2, 1/4. So you can see that we have exactly the same shape, but the opposite direction. So there is the graph of G, okay? For those of you who have been kind of curious about this, if you want, you might note that f of x is monotonically increasing. So if we march along f from left to right, it is always going up, whereas g of x is monotonically decreasing. So kind of a fun little way to apply something that we mentioned earlier. Okay, now back to the problem at hand. Let's talk about domain, range, and asymptotes. So we've said this before, but I'm going to use this video to really drive this home. The domain of an exponential function, unless it's being composed with a function that has domain problems, is all real numbers. So the domain is all real numbers. Notice nothing has really changed. The shape of the graph has changed, but from the domain, range, asymptote standpoint, everything is the same. The range is still all positive numbers, not including 0. And the asymptote is still the x-axis, aka the horizontal line, y equals to 0. So that's our first example. Now let's move on to our second example. So same thing, let's list the transformation. So notice that here, the only thing that's different is this plus 1. And what I'm hoping is that you'll say with me as I'm writing this, the transformation that we have here is a shift up 1 unit. Okay? And again, thinking about points, shifts up impact the y-coordinate. So the x-coordinate is not impacted here, it stays the same, but the y-coordinate increases by 1. So if we go back to our graph here, the point 0, 1 goes up to 0, 2. The point 1, 2 goes up to 1, 3. The point 2, 4 goes up to 2, 5. The point 3, 8 goes up to 3, 9. And then down here, same thing. So this is going to go up to 1.5. This is going to go up to 1 1/4, 1 1/8, and so on. So here is that graph. Again, same exact shape, but everything has been shifted up by 1 unit. Now, notice that since in the original, the black graph, as we were moving further and further left, the y-coordinates got closer and closer and closer to 0 without ever getting there. When we shift up, we see the exact same behavior, except now we're getting closer and closer to 1, not closer and closer to 0. So what you'll see is that this shift up is going to impact both our range and our asymptote. All right, so again, the domain, we're almost going to get bored of this, but we're still going to do it. The domain is all real numbers. Now for the range and the asymptote. So again, that shift upward impacted our range to where now it starts at 1, and it impacted our asymptote to where it shifted up also. So the asymptote is now the line y equals 1. Okay, next example. So here we have 2 to the power x minus 3. So you'll notice the kind of changes in the exponent. X was replaced with x minus 3. So say it with me. The transformation here is that we have a shift to the right 3 units. Okay. So this is a transformation that impacts the x-coordinate. So if we start with a point x, y, that point is going to get shifted right. And shifting right means we increase the x-coordinate by 3. So it becomes x plus 3 comma y. So let's graph it. So the point 0, 1 becomes 3, 1. The point 1, 2 becomes 4, 2. The point 2, 4 becomes 5, 4. The point 3, 8 becomes 6, 8. Same thing here. Negative 1, 1/2 becomes 2, 1/2. Negative 2, 1/4 becomes 1, 1/4. And so there is the shape. Same exact shape. Just everything was shifted to the right. So one thing you might notice here is, as far as domain, range, and asymptote are concerned, this shift impacted nothing, okay? So what some of you might be noticing is like, wait a minute, if the transformations only impact the x-coordinate, since the domain was already all real numbers, it's not changed. And since the asymptote is horizontal, only vertical shifts and vertical transformations are going to impact it. So we see that the domain is still all real numbers. The range is still the positive numbers, not including 0. And the asymptote is still the line y equals to 0. All right, last but not least, j of x. So in this example, we actually have 2 transformations, right? So you remember from our transformations unit, there's no requirement that there's only one transformation acting at one time. So there's that minus and there's that 3. What some of you have been doing and have found helpful is to rewrite this as negative 2 to the x plus 3. That way you can sort of isolate the transformation. So if you're finding that helpful, great. So maybe say them with me. What does the negative on the outside cause? That's also a reflection in the x-axis this time. And then the plus 3 is a shift up 3 units. Okay, so the asymptote, the domain, and the range. We'll talk about those in a minute. Let's think about what happens to the points, right? So I think you all remember that just kind of as a rule of thumb, we generally start with the reflections first. We don't have to, but that makes it a little bit consistent and easy, and that's just what we do. So the reflection in the x-axis is going to make the y-coordinate negative. So this reflection is going to cause the y-coordinate to become negative y, and then the shift up adds 3 to the y-coordinate. So it'll be negative y plus 3, which we can also write as 3 minus y. So let's look at the graph. So the point 0, 1, I'm actually going to trace it through. 0, 1, reflect in the x-axis, that gets us to 0, negative 1, and then up 3 units. So that lands there at 0, 2. Okay. Let's do 1, 2 next. Reflect in the x-axis, and then up 3 units. So it lands there. Next, 2, 4, reflect in the x-axis. That lands there. And then up 3 units. That goes up to here. And then let's just do 3, 8 to finish. So 3, 8, reflect in the x-axis. That lands there. And then up 3 units. That finishes there. So like that. And then really, really quickly, negative 1, 1/2, reflect in the x-axis. Up 3 units. That lands there. And the next one, I'm not going to like laser pointer through it. It's going to be this point here. It's going to continue that same trend. I encourage you to walk it through on your own. But here's what we see. So we see the reflection and the shift in the graph. All right, so let's talk about the domain, the range, and the asymptote. So the domain, you guys are probably thinking, ugh, what a broken record. Yes, we get it. The domain is all real numbers. True story. The domain is all real numbers. Now let's look at the range. So this time, the range doesn't go all the way up, 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 up. It goes down. The sort of tendency on the y-coordinates is that they approach 3 without ever getting there, and they approach 3 from the bottom. So the range is from negative infinity to 3. And then lastly, for the asymptote, so we mentioned this in the h of x example. The asymptote is going to be transformed by the shift up, just like everything else. So the asymptote was, before we transformed it, the x-axis, y equals 0. The shift actually causes it to go up to y equals 3. So here we have 4 examples of transformed exponential functions. And I want you to notice, and I mentioned this in the previous video, but I want to kind of really, really reiterate it, the shape of an exponential function is this shape here. Depending on the base might make it steeper. The base impacts the steepness. So how steep this curve is. And transformations might, shift it, flip it. But the basic shape remains the same. This shape, where there's a gradual increase first, and then very, very rapid increase as we continue going, that is tradition. That is kind of the classic exponential shape. And when you hear people talking about exponential growth, That's the pattern that they're referring to. A very gradual rise at first, followed by a very rapid increase in the steepness to the point where it looks almost vertical very, very quickly. Almost vertical, shooting upward very quickly. So this is a little more on the basics of exponential functions. Stay tuned for more about exponential functions coming soon.